Show that the derivative with respect to y of y log 2y minus y is log of 2y. The diagram shows the curve with equation this. The point P lies on the curve, the shaded region bounded by the curve, and the lines x equals 0, y equals half e to the 4. Find the exact volume of the solid produced when the shaded region is rotated completely about the y-axis. So let's have a look at this then. I've got this part summarized here. Okay, the first thing to do is get this derivative then. I've called it f of y, so part 1 here. Just differentiate with respect to y instead of x, isn't it? So it's the same process identically. So df dy then is a product rule, and this constituent part is a function of a function. So applying those rules, it's u. dv, log of something goes to 1 over the something, multiplied by the something differentiated, plus v times du, minus, the next thing, differentiate this, y differentiates to 1. So basically we treated the symbol y here as though it's our customary x, in that we're just differentiating with respect to the symbol. So here the 2's cancel, the y's cancel, 1 take 1 cancels, and it's just log of this 2y, which is what we wanted to show. Part 2 then, we need to find this shaded area. In part 2, the volume of this shaded area we'll label as V. So we'll call it V then. And basically, I've just done half the sketch here, and I'm going to rotate these discs. I've already done the disc here, illustrated in the picture. So we're going to sum these volumes. We're going to sum them from the bottom of the curve. Let's just flick back and check the bottom is the minimum point here. When x is 0, we get 1, don't we, in the curve? If we put 0 in here, we get, oh, a half times e to 0 is a half. So let's put that in the picture then. So this lowest point here is a half and 0. X is 0, y is a half. Here, so we're going to go from sum the discs from a half up to the y value here, which is a half e to the 4 of these discs. Their thickness delta y, so that's dy, and the volume of the disc, the thickness is that, the area is pi r squared, so it's pi times x squared. So that's equal to then, it's the integral between a half and a half e to the 4 of, bring the pi out to the front, of x squared dy. Now what is x squared? So I'm just going to look at that now, because we've got here, so I'm just going to put x squared here, so 2y in the workings in the picture is equal to e to the x squared. So take logs both sides, in other words, write this in log form. The e swings down and the x squareds drop down to ground level, and the e swings down and it's log of 2y, because e becomes the base of this logarithm. So you visualize it like the e swinging underneath, dropping the x squared to ground level, and it's log of 2y. So that's what we're going to use then. X squared is log 2y, so this is log 2y. We've already worked out the integral there because we did it in part 1, didn't we? This differentiates to this, so the integral of this is this, y log 2y minus y. So there's the integral. We times it by pi, of course, and we're going to evaluate that between a half and a half e to the 4. So we've got to be careful here. Pi, top value, take bottom value, and see what we get. So it's going to be a half e to the 4 then, times ln of 2y, so 2 of these is going to be e to the 4, minus y, which is a half e to the 4, minus the bottom value, put half in here, log 1 is 0, thankfully, minus a half here. So the log 1 was 0, so that was good. So what do we get then? We get pi. Log e to the 4 is just 4, isn't it? Because the 4 comes down as 4 log e, which is 4. 4 times a half is 2 e to the 4 then, minus a half e to the 4 here, plus a half. I think we'll take out a half, so it's pi over 2, bracket. Now we've got 2 of them minus a half of them, which is 3 over 2. We've taken out a 2, so it's 3 e to the 4 plus the 1 that's here. So that's the volume then of the curve generated in part 2. Okay, let's look at part 3 now. Here it is here. Let's go back to the original question, because it was a long question here. Hence, find the volume of the solid produced when the region bounded by the curve, the lines x equals 0, x equals 2, and y equals 0 is rotated completely about the y-axis. So it's just this region here, isn't it, that makes it into a cylinder. So if we go back to our picture then, let's find out the volume of the total cylinder. So I'm just going to draw this sketch here roughly. So this distance is 2, and this is the whole cylinder here then. So you can visualize it like that. So I'm going to just do the volume up here. The volume of the cylinder is pi r squared, which is 2 squared, times the pi r squared, which is 2 squared, times the height, which is a half e to the 4, which is equal to 4 over 2 is 2 pi e to the 4, 2 pi e to the 4, that looks like it. So here for part 3 then, answer is 2 pi e to the 4 minus pi over 2, 3 e to the 4 plus 1, which equals, well, let's leave the pi, I'm going to put a 2 here, and this will then be a 4. So it's pi over 2, and this will be 4 e to the 4, take 3 as e to the 4, take away 1. Let's just double check that. We've got 4 e to the 4 to bring into the bracket, because we've got the pi over 2 outside. Take away the 3 e to the 4, it's just 1 e to the 4. Then the minus 1, of course, at the end, put in as well. So that's the answer.